Hello everyone, I am Tanishq Sharma and in this session I'll walk you through how Liquid Galaxy tools can be automated using a clean scripting architecture with precise control over timing and execution. This is part of the GSoC 2026 pre-requirements for Liquid Galaxy where the focus is not just on visuals but on reliability and synchronization. We will look at how these tools are created and how the commands flow. So, what exactly is Liquid Galaxy? Liquid Galaxy is an open source platform for immersive multi-screen visualization. It was originally created by Google engineer Jason Holt to run Google Earth across a cluster of PCs, but it has since evolved far beyond that. At its core, Liquid Galaxy is not just multiple screens showing the same content. It is a distributed rendering and synchronization framework where several machines work together to behave like a single continuous visual display. This allows real-time, high-resolution and immersive experiences that would be difficult or inefficient to achieve on a single machine or a single display. Today, Liquid Galaxy is used for 2D and 3D virtual tours, geospatial data analysis, and interactive visualization systems, where precise synchronization across displays is critical to maintaining visual consistency and immersion. Now, let us understand what are tours in Liquid Galaxy. A tour is a scripted, automated navigation sequence that controls how content is displayed across the entire screen system. Instead of manually moving the view, the system follows a predefined path, zooming, rotating, and transitioning smoothly between locations or data layers. These tools are widely used in environmental monitoring to visualize climate or terrain changes, in geospatial storytelling to present data driven narratives, and in training and simulation where consistent visual guidance is essential. They are also valuable for global infrastructure planning, helping teams explore large scale projects in a clear and immersive way. So this is an example of a tool that I created for another task of Liquid Galaxy. Here I am just rotating around a 3D pyramid and showing it from different sides. Yes, here it is. But this is just a really small use case of what tools can do, and I'll later in the demonstration show what we can actually uh, create using tools. So, how are tools built? Uh, at a high level, tools are created using a combination of KML files and programming. The fastest way to generate the complex coordinate data needed for a tool is by using Google Earth Pro. The steps are as follows. First, open the desktop version and click the recorder tool button in the toolbar. Once finished, stop the recording and save the tool. You can now export it as a .kml from the Places panel. For more control and for more specific timings, the KML can also be written or generated programmatically. This allows precise timing and synchronization across the master and slave screens. Finally, the KML is uploaded to the master machine, which plays the tool across the entire Liquid Galaxy system. So now it is time for the demo. Now let me demonstrate how to create a tool using Google Earth Pro. Let me quickly spin up Google Earth. You can download Google Earth Pro from the official link from the official website of Google. So this is Google Earth Pro. Go to this record a tool button, start the recording. Now let us see, this is the Taj Mahal. Taj Mahal, Agra. Okay, search. And the view is changing to focus on the Taj Mahal. The Taj Mahal. This much should be fine for a demonstration. Now the tour has been recorded. Let's save the tool. Let's name the tool as Taj. Click OK. And now we are going to click on the right click on Taj and then click on the Save Places as button and save Taj as .kml. Save. So now it should be saved. The file should appear here. Yes, here it is. So now let us quickly open it in Notepad. Open with Notepad. This is the file. Control A, Control C. I've copied the whole file. Now I'll come to VS Code and paste the file in task.kml. Okay, so now it is set. Project that I have created to demonstrate the application. This is the application is running on Android emulator on Google Pixel 7, and I'm running a 3 rig LG 3 virtual machine, one master and two slave nodes. Yes. So now let me quickly hot restart the app. In the meantime, let us see how the application works. First, we are establishing connection on the connection screen, and then the main function is on the main screen where there is one button present with the start mission tool written on it. Then clicking on this button calls the function underscore run tool, and on running this function it first checks that the connection should be established. After that it uploads the it first takes all the content of task.kml file and stores it in tool.kml, and then it uploads that kml string with the name task.kml to the master machine. After that, it starts the tools named Taj. This name Taj is very important as it is the name that we provide in the name tag below the GX tool element right here. So the application has restarted. We can come here, check for connection, connect to LG, back. Let's start the tool. Started successfully. This is the wrong tool. Why am I getting the wrong tool to start started or to restart? Connection, connect to LG, start mission 2. Yes, so the tour has started now. I think the hot restart wasn't the hot restart wasn't successful back then, so I hot restarted it again. The machines may appear out of sync. This is some kind of a weird glitch which can be corrected by just typing in LGD launch in the master machine's terminal. So as we can see, the tool is loading, and this is the tool that I created from the Google Earth Pro. So this is all for this demonstration. So now coming back to the slides, let us talk about the second method, that is writing or generating KML programmatically. So what exactly is KML? KML stands for Keyhole Markup Language. It is an XML based file format used to display geographic data in Earth browsers such as Google Earth, Google Maps, and Google Maps in mobile. KML was originally developed by Keyhole I Inc. which was later acquired by Google in 2004. Today, it is maintained as an international standard by the Open Geospatial Consortium, making it widely supported and interoperable. Because KML is based on XML, it follows a strict tag-based structure with nested elements. These tags define geographic features like place marks, paths, styles, polygons, and camera movements, camera positions, etc. KML files are typically saved as .kml for uncompressed data or .kmz when the data isn't compressed. In Liquid Galaxy, KML acts as the core format for defining visual content and camera paths, making it essential for building and running tools. Now, let us talk about some common KML elements. These elements are commonly used while building tools. First is the look at tag. This element simplifies navigation by keeping the camera focused on a specific point on the ground. It's defined using attributes like longitude, latitude, altitude, range, tilt, etc., making it ideal for smooth and guided viewing. Next is camera. Unlike lookat, camera provides full 6-degree freedom of control. In addition to longitude and latitude, it includes altitude, heading, tilt, and roll. This allows more cinematic and flexible camera movements, especially useful for advanced tools. The place mark element is the fundamental unit of KML. It represents a feature on the map and can contain points, lines, polygons, styles, and descriptions. Next is the line string element. It is used to draw a line between multiple coordinates. It is commonly used to visualize paths, routes, or boundaries. Next is the polygon element. It is used to highlight areas. These polygons can also be extruded, allowing the creation of 3D shapes and volumes. Next comes the network link tag. Network link allows one KML file to dynamically load another KML file. This is useful for modular designs and real-time data updates. Finally, screen overlay places a static image on top of the screen, such as a logo. It is independent of the globe and is often used for legends, UI elements, or logos in Liquid Galaxy tools. Here are some example snippets. So this is we are using a network link here. We have named it live updates. This is the link tag. In here, this is the link that we are referencing. This is the refresh mode is on interval and the refresh interval is 1, and here's the closing tag. Similarly, here's an example snippet of how place mark is used. This is the name of the place mark, my marker, and these are the coordinates. So now, how to create tools in KML. KML tools are built using a set of GX extensions which allow time-based and animated navigation. The main container is GX tool, which holds the entire tool definition. Inside this, we use GX playlist to define the sequence of events in the tool. Each event is executed in order, creating a smooth guided experience. To move the camera, we use the fly to tag. This element controls smooth navigation to a specific location using either a lookat or a camera view, along with the defined duration for the movement. If we want to pause between actions, we use the wait element. It allows us to control timing and pacing within the tool. Next comes the animated update element. It is used for dynamic changes during the tool. It allows modification of place marks, styles, or visibility while the tool is running. Next is the sound cue element. It is used to play an audio clip synchronized with the tool. By combining these elements, movements, pauses, updates, and audio, we can build fully automated and synchronized tools for Liquid Galaxy. Next, here are some additional features that may come in handy while building a tool. To create an orbit effect, you can gradually adjust the heading or roll values, which produces smooth circular camera motion around the location. For zooming in or out, simply modify the altitude or range parameters to control how close the camera is to the ground. For smooth transitions between different views, the fly to element should always be used instead of abrupt jumps. You can also customize how place marks appear using icon style, allowing you to change icons, colors, or scales. Using play mode element, you can enable user controlled play and pause behavior for media content. And finally, experimenting with different altitude modes such as climb to ground, relative to ground, and absolute helps achieve better visual perspective and depth. These small features greatly improve the clarity, smoothness, and overall quality of the Liquid Galaxy tools. Now, moving on to the demonstration, let me quickly set up. Now, let me quickly demonstrate how to create your own KML file programmatically. So, this is the same project and I've created another KML file. The project is same as the one that I used to demonstrate how to use Google Earth Pro to create a tour. This is the KML file. Let me explain the KML file. First, we are having the XML tag as this is an XML file. The encoding is UTF-8 and this is the version. Then comes the KML tag to specify that this will be a KML file. Then the document tag with the name Seven Wonders of the World. It is the name of the document. Then comes the GX colon tour tag. This is the main point from where our tour starts. Note is that this is not the name of our tour, but the name element that comes after the tour element is the name. As in this case, this is Taj. I can also change it to, let's say, Wonders, and then I'll have to come in the main screen and change the tool name here too. Now the tool name should be same in both these places in this name tag, and this is the one you specify with lgservice.start2. Then comes the GX playlist element. All the nested elements within GX playlist element are to be executed in a particular sequence. So first the fly to element will be executed. After that the wait element will be executed. After that this fly to element will be executed, and so on. So then in the fly to element, we are having the duration. What this duration is actually doing from the initial camera position will fly to this camera to these camera coordinates in the look at tag. So this duration specifies that it should take exactly 3 seconds to fly from the initial camera position to the final camera position that is specified in this look at tag. The fly to mode should be smooth for good UX. And then comes the look at tag. We have specified the longitude, latitude, altitude, heading, tilt, and range here as per the visual appeal. Then we are closing the element and then we are using the wait tag. So, and providing the duration as 10 seconds. What this wait element is doing, once let's say we visit the Taj Mahal. So in 3 seconds it will the screen will be rendering the Taj Mahal and it will stay on that screen for 10 seconds. So this is the so as the element itself suggests wait, so it waits on that monument the specified duration before moving on to the next monument. So let me quickly restart the application. Let me just restart it once again. Okay, so the KML file should be loaded now. It's loaded in the application, not to the LG rig, of course. Then connection will connect to the LG. Then now we can start the tour. Started successfully, and notice this timer. In 3 seconds, we reach the first monument, and at 13 seconds, we will be departing from this monument to the next monument. Let's see, exactly at 13, and at 16, we'll be reaching the next monument. As the time, the duration to reach the next monument is 3 seconds. Then at 26, we'll be departing from this monument, and so on. The the tour will execute itself in a particular sequence as specified in the KML file. So this is a basic KML file. We can also add different functionalities like waiting on a particular monument and rendering it from from different angles, touring around or orbiting around the monument from various angles, and also adding different let's say 3D elements to improve the user experience and make it visually more appealing. Also, I am currently not using any balloon or any place markers. We can also add those to improve the user experience and to identify different places. So this is all for this demonstration. Thank you.